Let's review the L'Hopital's rule applied to indeterminate form 0 over 0. If we're evaluating the limit as x approaches a of f of x over g of x, and both f and g approach 0 as x approaches a, we end up with the indeterminate form 0 over 0. So if the limit as x approaches a of f prime of x over g prime of x, notice that this is not a quotient rule of differentiation, it's just a derivative of the numerator function f over the derivative of the denominator function g. If this limit is equal to L, where L is either a finite number or infinity or minus infinity, then the original limit as x approaches a of f of x over g of x also equals to L. But if we keep getting indeterminate forms such as 0 over 0, we have to repeat L'Hopital's rule until we no longer end up with an indeterminate form. Okay, so let's look at an example. Limit x approaches 0 of x times sine of 4x divided by secant of 3x minus 1. As x approaches 0, clearly the numerator goes to 0, and recall that secant of 0 is 1, so denominator also approaches 0, and we have the indeterminate form 0 over 0. So we can apply the L'Hopital's rule here, and that means we look at the derivative of the numerator and the derivative of the denominator and take the limit of the quotient of those two. To take the derivative of the numerator, we have to use the product rule. So x times cosine of 4x times 4 plus sine of 4x. This is the derivative of the numerator. And the derivative of the denominator is secant of 3x times tangent of 3x times 3. So let's rewrite this by simplifying and by making it look neater. This is not another application of the L'Hopital's rule. It's just cleaning things up. The numerator is sine of 4x plus 4x times cosine of 4x, and the denominator is 3 secant of 3x times tangent of 3x. As x approaches 0, once again, numerator goes to 0 and denominator goes to 0. So we can apply the L'Hopital's rule again, this time to this function, sine 4x plus 4x cosine 4x over 3 secant 3x times tangent 3x. So let's do the same thing we did before. We're going to take derivative of the numerator and divide it by derivative of the denominator. This is 4 cosine 4x, and applying product rule again, plus 4x times minus sine of 4x times 4 plus 4 cosine of 4x. And the denominator, we can treat this also as a product of two functions. This one is the first, and then tangent of 3x is the second. So this is 3 secant of 3x times secant squared of 3x times 3 plus tangent of 3x times 3 secant 3x times tangent of 3x times another 3. So again, let's clean this up and take the limit of function written in a nicer way. So this is limit x goes to 0. In the numerator we have 4 cosine 4x and another 4 cosine 4x. That's 8 times cosine of 4x. And then we have minus 16x times sine of 4x. And in the denominator we have 9 secant cubed of 3x plus 9 times secant of 3x times tangent squared of 3x. Let x go to 0, but this time notice we do not get the indeterminate form 0 over 0. In the numerator, 16x sine 4x goes to 0, but 8 cosine of 4x is going to 8 as x goes to 0. So this is equal to 8 in the numerator. In the denominator, because tangent of 0 is 0, the 9 secant 3x tangent squared 3x term goes to 0, but secant of 0 is 1, so the 9 secant cubed of 3x term approaches 9, and that's our final answer. The limit is equal to 8 over 9. So let's summarize. We use the L'Hopital's rule twice to evaluate the limit as x goes to 0 of x sine 4x over secant of 3x minus 1, and we found that this limit was equal to 8 over 9. For more videos, visit www.mathprepvideos.com.